So we've got a UH4 wired in a bad location. You can't get to the connections because it's tucked up the back of this box in, so that's in a poor location. First thing I noticed when I got here, this cable here, which was the heat enable, it had that connection in the LS connection, but actual no live connection in the return. So it was getting no signal upstairs to activate the boiler. So you turn the thermostat on up there, it activated the UH8, and then it started the pump, it opened all the valves, but no, the bin didn't fire the boiler up. So downstairs it's been getting heat indirectly from whenever the radiators have been called for upstairs, or the hot water. So the heating's been working intermittently because of that anyway, but also the setup downstairs is not good. So even if it was wired correctly and done correctly, it still won't function properly down here. So yeah, that's a few. First thing that I've noticed here, you know, just poor install in general, connections not done right. We've got a twin and earth used at this point here, so it's only a 2-core and earth. So they've used the earth connection on as actual live conductor. So that's got no insulation inside a twin and earth, so that's not how it's supposed to be used. And then what they've done is they've took it to behind this TV plate. I thought this was a TV plate, so this has just been used as a blank plate, if you like. And there's the twin and earth. So instead of using a piece of 4-core from there to there, obviously that 4-core wouldn't reach. So he's used a piece of 3-core twin and earth from here down to here, jointed it, and as you can see, there's not enough cores in the twin and earth to be able to use these. So they've used the live as a permanent live, the earth, which is sleeved up as an earth as well, as a switch live, and then blue as the neutral. And then inside the UH8, UH4 even, that's the connections there, here. So all 4 are connected, so you've got a permanent neutral, permanent live, switch live, and then an earth connected. So that earth is actually connected inside there. Yeah, it's twisted up here and not used. So there's lots of connections being done, like people are putting the right cables, coloured cables in the correct connection, in connections that say live and earth and neutral on, but actually they're not connected into the right place. So, and then also all these valves are just actuators, we're all connected into zone 1, so we've just got one thermostat controlling all these, whereas it should have been at least, you know, 3 thermostats controlling all these different areas. No labelling of the pipework as usual. So I'm, again, same thing, having to work my way through this, identify each heating loop. Whilst I'm heating the loops up, I'm identifying problems with the wiring and my, you know, connections in here. So now I've just temporarily stuck that cable in with the pump enable connection. So when we activate the thermostat, it enables boiler enable and it enables pump as well. So I know we're getting a live connection when the thermostat's activated. So I've turned the thermostat on. I've just stuck the boiler enable cable into there just for the time being, just to see if the boiler fired up, and it did. So the connections, like I say, have just been done wrong down here. We've got heat down here now. So like I say, identify this, and then I'm working upstairs. I'm probably gonna have to take all the connections back out the wiring centre and redo it. We'll have a look at that in a minute. So the layout in here is just all this room, and then the front lounge is on this one thermostat. So the front, we've got single pane glass in this property. Yeah, and so what happens is they're saying that the front room never gets to temperature. It's like it's cold in there. So they were gonna add an additional radiator in there to try kind of boost the heating. So the reason why it's been cooler down here, but they've had some heating, is because this has been calling for heat, firing the pump up, opening the valves and just circulating cold water. When the hot water or the heating upstairs, the radiator thermostat turns on, that does fire the boiler up. So these are just here, just circulating. And as soon as that hot water is called for upstairs, you know, for the heating or the hot water on the radiators on the first floor, that hot water then also comes down here and circulates around the underfloor heating. So that's one of the reasons why they've not been getting heating down here. And the other reason being is they have to have this pumped up to like 24 for that room in there to try and climb to temperature. And then it's a lot hotter in here. So that room in there has got, and in here it's got a timber floor, but in here it's got tiles. So the heat gets through this floor a lot quicker than what it does this wooden floor. Plus you've got a difference in temperature, you know, in this room here, just because of the shape, size, amount of glass that's got double glazing in them doors there. And then this room is taller roof, single pane glass. That's tall roof, single pane glass. So these areas are cooler naturally because of, one, the amount of time it takes the heat to get through the timber floor. Two, because you've got the lack of insulation with the single pane glass, the single glazing. So that room in there requires its own thermostat because that's going to take longer to get to temperature. Same in here, requires its own thermostat. And then in here requires its own thermostat. So on top of it not calling for heat when it's required down here anyway, and it's just getting it indirectly. And then two, amount of thermostats, the locations they put. So just doing some identifying of floor loops now, so you can see that we've got heat down here. Yep. And you can see the pipe running around the edge of the floor there. And that does this room. So circuit one is snug. So we're just identifying the kitchen now. We've just put circuit 2 on now. You can see that is heating up. The pipe work you can see is not laid very evenly. There's big gaps here in it. Normally it's quite tightly and neatly laid, whereas it looks a bit, you got really bright bits there on the right and blue gaps in the purple gaps in the middle there where the floor's cold. So yeah, the pipe work in the floor hasn't been laid very well. So this is the circuit that we're on at the minute. There's also a gap here at the end of the kitchen where I'm stood, where there's no heating. So from the door frame, there's about 1.5 meters with no heating. And then as you get into the kitchen where the fridge is, it's about 1 meter. So there's a meter of heating missing there, and then from here there's 1.5 meters missing to the door. But anyway, that's that loop. Also, the radiator in the ground floor hallway appears to be working with the underfloor heating. I don't think this is piped to the manifold, because if it was, I wouldn't have popped the circuit off yet, so this still would be cold if it had its own independent circuit to the manifold. So how this looks, it looks like it's teed into the plumbing that supplies the manifold. So circuit 3 is this section that was missing at the end of the kitchen. This meter and a half is missing at the end of the kitchen. We're identifying the dining room now. So we're on zone 1, 2, 3, 4 at the minute. So we've got 2 for kitchen. Like most of the kitchen is that one, and then a very small section is that one. The snug we've already identified, there's a blank there, and then we're on this one. So yeah, that looks like half of the dining room by the looks of it. Yeah. So that loop does half of the dining room. So we can whip that over now and do the next one. I mentioned before that the radiator in the hallway was getting hot. So I've isolated upstairs the hot water, and I've isolated the first floor, second floor, first, second, third floor radiators. Yeah, so I've turned the valves off upstairs, I've turned the controllers off, and I'm focusing my attention on this because they did mention before that there was kind of a crossover of when they put the hot water on, the radiators come on, and they were told that there was some sort of reverse feed with the plumbing or something like that, and I just said I don't know. I was hoping it was going to be a valve that was faulty or a valve that was missing or something obvious that I could tweak to get it working. And what's happening in the house is everything just comes on together. So you've got a separate controller for the hot water, which opens and closes the hot water valve, fine. And then you've got a thermostat on the landing, which opens and closes the other valve upstairs, which is supposedly for radiators, which works. And so that opens and closes. But regardless of whichever area you call for heat, it just heats the entire house. So if you put the hot water on, all the radiators get hot, and it also drags heat down to the underfloor heating down here. So there's no zone valve isolating the underfloor heating, but obviously you've got these actuators. So, but if, say for example, this has been just switched on here, and when they turn this on, it didn't fire the boiler up, so it was just circulating cold water. But if the hot water called upstairs or the radiators called upstairs, it just fires hot water down to it, and then it heats the underfloor heating. So they were getting some form of heating down here, but we've just discovered that that radiator was hot, and I thought I'll just go upstairs and check all the other radiators, and yeah, all the other radiators are also hot just while I'm testing this down here. So if you call for hot water, it heats all the house. If you call for radiators, it heats the whole house. If you call for underfloor heating, it heats the whole house. So that's been on. You can see that radiator's been on. So this thermostat has been on standby all day, so the valve's been closed, and I've had the the hot water switched off as well. So there's no accidental crossovers of anything, just while I'm doing the testing. So there you go, you can see that radiator's been on. That one as well. Oh, all right, mate. That one. And then the third floor, you can see that one's been on as well there. So, in here, we've got a valve which was for apparently for the heating, and then a pump there which is for, again, assisting the circulation of the heating. This pump is for circulating the hot water around the taps, so there is hot water on demand at the tap whenever you open the tap. When you open the thermostat on the landing, which is for the radiators, it opens this valve and it starts that pump. All the radiators are still getting hot even with this in the closed position. So apparently this valve's been changed. If it was a faulty valve, that's one reason that could be doing that, but apparently this has been changed. So I'm ruling that out based on, I've been told this has been changed and that has been checked. So I'm basing that on that. This one here, again, it's working off this timer here, which, you know, that has been on. So what I've done is I've isolated the tank stat here to make sure that this valve doesn't open. So that has been, again, off all day. So this has been off all day, and that has been off all day, and I'm just testing the underfloor heating downstairs. And while I've been testing all them loops to do the labelling and identifying the circuits, all the radiators have been getting hot. And then also, the customer said before I even got here that when they turn the hot water on, when they have the hot water on, sorry, all the radiators get hot. So I've just done that, you know, I'm going to do that next just to double check that. But it seems in every scenario, so once this valve is open and the thermostat on the landing's calling, all the radiators get hot. When this opens and is calling for water, all the radiators get hot. And when the underfloor heating downstairs is calling on any of them circuits, all the radiators get hot. So I can't see any of the pipe work. Normally there'd be some pipe work saying, you know, towel rails, if you separated that, radiators, underfloor heating, hot water. And all I can see here is flow and return, main, cold. So usually you'd have the flow and return coming into here, but then you would have teed off the flow for towel rails. Again, if you've got that, that's just an example. But in this scenario, you would have the flow coming in, and then you'd have hot water valve, radiator valve, underfloor heating valve, and they'd all be in an accessible position. But whereas in here, it just, yeah, that's tapped off the flow there, and I can't see any labelling on any pipe work that says radiators, or whereas everything else has got some sort of label on. The underfloor heating hasn't got any labels on, but the copper pipework seems to have some labels on, and usually it would say, you know, hot water, radiators. So yeah, whenever the boiler is calling for heat, there is water flowing around the system and getting everywhere, regardless of any of these controllers. You know, apart from this, obviously this stops the hot water coming to the cylinder, and that seems like that's working okay. I've tested this open and closing, I've tested it using this, using the controller, and then you can feel the temperature of the pipe work in here. You can feel it getting red hot, and then you can obviously, now it's cooled down. So that seems as though that is stopping the water flow when it needs to and allowing the water flow when it needs to, and all the relevant controls are switching the valve. So the hot water seems to function okay, but whenever like I said, whenever the boiler is calling for heat, there is water getting around the entire system. So that's what's going on up here anyway. As you can see, it is a totally messy wiring centre. There's bits of stranded cable not just hanging out of the connector blocks, not twisted together properly. So some of these connections are hanging on by a thread of the stranded cable. So the connections are really bad in there. That fan switch seems to isolate the heating. It's very confusing, the wiring, how it's done. And then in here, we've got the boiler in this cupboard. We've got the FCU there. And again, a kind of bundle of cables just coming through the back box, and cable, that flex, I'm assuming that, I think that flex is the one that goes over to the room that we've just been in, and that gives a supply over to there and brings some of our switch lives back in. So that's all like the kind of connections done there for the control from the thermostats and stuff like that. So let's see, circuit 6, is it? So yeah, circuit 6 we're testing at the minute. Seems to do the other half of the dining room. gradually getting warm, and there wasn't anything there before. Nothing in there yet. So we've removed the old thermostat and the wiring. There was what I mentioned before. They used the earth cable as a live conductor there. So just put a bit of earth sleeving over it. So that's potentially dangerous, because if someone ever connects onto this earth at either end of that cable, thinking it's an earth to pinch an earth from something or pinch a supply, they're actually going to be putting a live supply directly to whatever the earth is on their accessory or thing they're doing. So that's dangerous. That should have been labelled up with a brown sleeving anyway, but also that shouldn't be done, because that is an uninsulated piece of copper cable within the twin and earth. And installations like this, like a domestic property, cables buried in the fabric of the building, should be double insulated. Yeah, so that would be a live conductor that was just insulated by the outer insulation of this and had no basic insulation on the inside, which is what the brown and the blue are. So there's lots of reasons why that isn't right. So yeah, there's been lots of poor electrical work in here. I've removed as much as I can. I've improved as much as I can. But some of it is just, there's nothing that can be done about it. So I've removed all the wiring that went to here, the joints, the wiring, the thermostat to there. I've rewired the pump to the new UH8, as that was not the best. So these are all labelled up now. So you can see I've labelled the pipework on the in and out sides the same, just in case one of these ever comes off. And they always label the actuators, because if somebody ever pops these actuators off for, you know, testing or whatever, if they're not labelled up, it's very easy to just put them on the wrong way round, and then you've got the wrong actuator controlling the wrong heating circuit. So as usual, you've got your 1, 2, 3, 4, 5, 6, 7, 8. So that is heating circuits number 1, 2, 3, 4, 5, 6, 7, 8. And then we know that snug is 1, kitchen 2 and 3, spare there, etc. So yeah, I've labelled all these up what they are now, so we know what the actuators do. We've labelled all the circuits up because he identified them yesterday with the thermal imaging camera. So there you go, you've got snug kitchen, spare, dining room, lounge, and then the same down the bottom as well. Originally, you could see it was kind of mounted partially up here, the UH8, so you could see the bottom half of it, but you couldn't get to the top half, so you couldn't get to the connections properly or get to the fixings. So I had to kind of like rip that off the wall to be able to get that down. So it was in a bad place for accessing for maintenance and stuff. I mean, this cupboard's got plenty of space in here, and it goes all the way up to here. So really, this cupboard should have been made bigger when it was done, because you can't fully access these pipes here easily. So the idea of this being in here is this is an access hatch to be able to work on this and maintain it. So yeah, this should have been made bigger, and then we could have just mounted this straight to the wall right above it, and it would have been nice and easy to work on, whereas I've had to mount it up on the edge here, because I couldn't mount it up there again because you can't access the connections to work on it. So I've had to mount it here, which isn't ideal, but the cupboard will, as you can see, there's a bit of lip left there, and the cupboard will just sit flush right up to this, and then it's nice and accessible now if you need to change any of these settings or get to any cables or add anything in future. Another thing we've also noticed is there's a lot of this verdigris everywhere on here. Now, that doesn't normally happen with stainless steel or plastic. Usually it's, I think, copper, brass, maybe zinc, where it oxidizes. So maybe the olives inside here are copper, where, you know, that the nut is tightening up to give it its watertight seal. So yeah, maybe the copper olives are rotting in here, hence we're getting this verdigris coming out. So these probably need taking out, draining down, olives replacing, giving a clean and putting back as well. And the only reason why we're kind of pointing this out is previously there's been a leak up there with the plumbing, and that was due to corroded copper pipes as well. So they've already had a leak due to that. This is another potential point of a leak happening. We have got 3 thermostats to fit to this system. We've got snug kitchen are going to be on one thermostat, as that's kind of one area. They're happy with one thermostat there. Well, so previously how this was done was this one thermostat opened all the actuators and was controlling this whole area, this dining room area, and then the lounge area as well. So certain rooms weren't getting to temperature properly, you know, and it was just a bad location to put it for doing all these areas. So underfloor heating doesn't really work like a conventional heating system. It needs as much control as possible. I think personally is ideal, because then we can isolate certain areas. And if you've got loads of UV coming through one room but not another one, this is south facing, for example, and this is north facing, this room's going to be considerably cooler and going to require a lot more energy to heat it than this one. So that's why you need, I think, the thermostat controlling as many zones as possible. One, for efficiency, so you've not got heating pumping out unnecessarily in a room when it's already at temperature and then it's too hot in there. It's like this can maintain its whatever temperature you set it at. So can this room, so can that room. So what we're going to do is, instead of this one thermostat that's in that location there, we're going to put a thermostat. They want it on the wall here, preferably. It's not the most ideal scenario to put it near corners, or I'm not going to put it into the corner, but move it out here a bit. But yeah, as long as it's away from UV coming in, as long as it's away from drafty areas, it's not near heat sources. Ideally, I would have liked to have put it here, but they don't want that. So yeah, we're going to put it here. So that thermostat then is going to do the kitchen and snug circuits 1, 2 and 3. It's going to control, and then we're going to have a thermostat over here above the piano, which is going to do circuits 5 and 6, which are dining room. And then we're going to have a thermostat over here. Again, I would probably rather put it in that corner away from the window, really, because these are single pane windows. But again, they said they want them as discreet as possible. So I'm going to put that there, and that's going to control circuits 7 and 8, which are this room. So this does control the radiators, because last night I had him to test, because I had everything off apart from the underfloor heating downstairs, and we still had heat coming through the radiators, but it weren't hot, it was just, you know, they were warm. So I said to him last night, just open the radiators and make sure that they get red hot, which you open the thermostat, this opens and that pump fires up, and they did get red hot. So this does do the radiator circuit. So yeah, I had it down for being a faulty valve, but apparently this has been changed now. People sometimes will just change the head and not the actual pipework, because the piece of brass pipework, the valve is in here. This is just a motorized valve opening and closing the valve. So the actual mechanical valve is inside this piece of brass. So sometimes it's that's sticking and not this. Sometimes it's both. So I've been told that the whole fitting has been changed, motorized head and also the brass joint at the back. So I'm gonna say that it's not that then, if that has been changed, because sometimes water can leak through these, and then there can be a bit of, if this is faulty, then if anything is calling for heat and the pump's running on the boiler, it can be forcing water down this partially open valve. So that would be the normal go-to, but in this case they're saying that that's been checked. So yeah, it must be some of the plumbing pipework in the fabric of the building that maybe isn't accessible. Also noticed there's a big gaping hole at the bottom of this that you can get I can get my fingers into the connections in there. So that's again more poor electrical work done. Right, so this is the only one that I didn't confirm. Last night I just left this running and told them just to keep their eye on it and hope the room gets to temperature, because yeah, they were going to add an additional radiator in here. So hopefully with this running as it should now, I've improved and repaired everything. This room should get to temperature, hopefully. So they did say that it felt patchy. Now you're going to have a couple of things. This is only coming through. It's not going to be fully through that yet, because it's only been on for an hour and a half. But you can see the gaps are quite big between the loops. So normally with the kind of prefabricated mat that you can get on the floor, you clip the pipes into, and they're normally quite close together from what I've seen before the screed goes over it. Whereas in here, there's the gaps are quite big. Yeah, about a foot. So the gaps are about a foot between the pipework. I'm not sure whether that's common practice or not, but yeah, maybe that's why it feels a bit patchy. You can see the gaps are quite large. But you know, when the floor heats up properly, the heat should spread through the wood a bit. It's just the wood's a really good insulator, so it just takes more time to come through the wood than what it does tiles. Okay, so that room's on. It's good. So underfloor heating all functioning now. Thermostat in here controlling this area. Old one gone. Thermostat there. Controlling the dining room. And thermostat there. Controlling the lounge. This is all tested now. Make sure it's all functioning. We've got some labels here letting you know what zones the thermostats are on. There's also some labels on the panel which I've done as well on the front.